So I'm here to talk about data pipelines with Argo, or cloud-native data pipelines. So sort of jump right into it, and I thought I'll sort of just explain what a dialect acyclic graph is. I assume most of you know it, but I'm just making sure that everyone's on the same platform. So basically, a dialect acyclic graph is a graph with no loops, so that basically you can only move sort of forward. The idea being you take some sort of data, you process it in steps, and sort of at every time it sort of moves ahead. It never goes back. Yeah. So with that out of the way, this is me. I work in Knowit ObjectNet in the principal engineers team. Previously, I worked in Limpro, Varnish, and IncludeOS. Currently, I'm doing sort of architect or prototyping stuff at the National Archives. I don't really know much about machine learning. I've been sort of dabbling a bit in it with it the last couple of months, and I'll talk more about that later. But I had this need at the sort of archives to actually process quite a bit of data. And I sort of started looking into some tools. So what they actually do is they take archive dumps, which are typically 50 to 800 gigabytes of data collected over a number of years, and they process it in various steps. They're actually starting to consider using some machine learning to do some metadata extraction on it, but that's not really the focus. The focus is take a bit of data, process it. So when I started sort of looking into it, a tool that was sort of commonly talked about was Apache Airflow. So it's a very sort of mature implementation of a workflow tool. It came out of Airbnb 5 or 6 years ago. So the fact that it sort of was born in 2014 is actually I would say the reason why there's something wrong with it, because 2014 is a long time ago. The thing I really liked about it is that you write your Airflows in Python. So for those of you who sort of had to sort of struggle with sort of these GUI workflow tools, writing thing in Python is quite convenient because you have access to everything. It's so much easier to debug than anything other. So when Airflow started out, I think like it was the way that it would sort of execute a step was to use Celery. So Celery is this implementation sort of a producer-consumer pattern where sort of you give a task and you put it onto a queue, and there's some consumer that is listening to that queue, picks up the tasks, execute it, and then puts the result back somewhere. And then what I found interesting was with it when I sort of was evaluating it was the support for Kubernetes, which was sort of, I would say, a more generic way to sort of execute steps in a workflow. So what's wrong with Airflow? The underlying thing that sort of I really disliked about it is that every step in an Airflow workflow needs to have Airflow inside it. So this is when I was running on Kubernetes. So every container needs to have Airflow installed inside of it in order to actually do the step. So I mean, for sort of traditional ML step, like a training step or something, that probably not necessarily that much of a showstopper. But if you want to sort of have this super generic, like a high-level overview workflow where you want to sort of have maybe 3 or 4 different teams working on different steps, having all of them having to know this very particular tool is not really that that nice. So at that point, I sort of stumbled across Argo. And to sort of, at a glance, it was sort of started, I think, 3 years after Airflow, which basically meant that it is cloud native. So cloud native, is that like a, do I need to say what cloud native is? Yeah, I should say what cloud. So a cloud native application is an application that you can sort of, it's built natively to run in a cloud service. Doesn't rely on having to be run in a VM, doesn't rely on sort of local storage. Typically sort of it is encapsulated inside a container, and that container can sort of appear magically, work for 5 minutes and then go away. That means that there are a lot of rules that you have to abide to, or 12 rules exactly, on how that application should behave. So Argo, the steps in an Argo workflow, for that to work, it needs to implement all of them. Or, yeah. So Argo uses, it's pretty similar to Airflow, but it uses Kubernetes for scheduling and execution. And the win was that the container doesn't know anything about Python or Airflow, so it can be anything. Also, what I sort of found really nice was that as the sort of workflow progresses, you produce some artifacts. I think that, for me, that was one of the sort of biggest gains I had from using this compared to something I would write myself, was that it sort of, you could spit out artifacts and it would handle it for me and move the artifacts from step to step. I'll talk more about this now. So during a workflow, the artifacts are sort of the files that are created while you do some sort of computation. What Argo does for you in each step is that before that step starts, it will inject the artifact into the container that you're running, or into the pod that you're running in. And then the step runs. And then after the step has completed, Argo will again go in and pick up any artifacts that you have created or modified and sort of put them back in the store. So for me, basically did two things. One was scheduling, like run this after this has finished. And then when step 2 is being executed, it has picked up the artifact from step 1 and injected it into that container. Is that clear? Yeah, great. Yes, and Argo has AWS S3 client built into it. I found that to be, because I didn't necessarily want to have a sort of hard dependency on AWS. So what I did was to have a Minios service, which is a S3 compatible object store that could run inside the same cluster. And that's both more performant because I don't have to talk to S3 in Finland or wherever. And it also sort of means that the cluster as a whole has fewer external dependencies. Now there's this thing that Argo has, because it's a native Kubernetes application, it relies on YAML. And this is my pretty simplistic workflow. So I'll try. Do you have a laser pointer? No, I don't. Okay. So we'll see. Maybe there's one in. Is there a way to get a red dot? Huh? I don't think it works. Yeah, but isn't there something in Keynote where I can push some button and it sort of there's a red dot or something? It used to be, at least. Okay. A laser pointer. Excellent. Thank you. Top button. Yes. So okay. So we'll try to sort of. So what's this? So that's basically what sort of resource this is. So this is the definition of a workflow. And then it has a name, or it has a generate name, which basically means that the tasks will be prefixed with this DAG demo. This is where it starts, and this is the DAG itself. So the direct acyclic graph, it starts here. So this is the first task, which is generate. So the first, and it uses the template generate data. That's defined further below. So you can sort of keep the DAG definition and the actual tasks, which are a bit more complex, further down. So generate will pass data on to consume, which has a dependency on generate. And so this is basically how the actual graph is implemented, is through these dependencies. So consume uses consume data as a template. And here we see sort of, I'm trying now to sort of inject an artifact into it. So I take the artifact data set, and this is taken from tasks. So that's from this workflow, and from the task generate, which is this one. And one of its outputs is an artifact, and it's called numbers. So this one generates some numbers, this one consumes some numbers. And then there's a final step here, which is called outputs, which is dependent on consume, naturally. It uses the template Argo cat. And then it has an input artifact, which is final sum. Yeah, it takes the final sum from this one, tasks, consume, outputs, artifacts, result, which is then defined further down below, and it sort of does something to it. It actually just echoes it. So this is the generate data step that was referenced above. So this is of a type script. You can sort of, script is sort of a quick and dirty way to define the task. So it uses the Docker container image Python Alpine, which is a small Python image. It runs Python, and this is actually sort of a way of inline define a script. So instead of actually putting that into the container, I can just sort of define it inline. So this just imports random, and then spits out a bunch of numbers on temp dataset.txt. And then there's some outputs here, and we call this numbers, and this was defined in the DAG above. And we take numbers from /tmp dataset.txt. So that's basically how it works. This is just because it supports compression of artifacts, and this is just a way to disable the compression. I think this doesn't do anything exciting. It just basically opens the artifact and sums it up. So it sums all the numbers up. Not really that much exciting. It has both inputs and outputs. But as you can see, they're more or less identical. And this is the last one. And here's sort of one thing I would just sort of dislike a bit about sort of Argo. There's many ways to sort of skin a cat, or many ways to sort of define a sort of template. And as you can see, I don't use the script, I use container here instead. So that's slightly different and has slightly different semantics. And I'm not entirely sure that they should have added that. I think it might have been easier if they sort of had one way to do things. So this one just references latest version of Alpine, and it just runs cat on that particular file. Yeah, and it has an input defined. Was that was okay, wasn't it? Yeah. Demo. Yeah, so this is, okay. I have this. I usually don't use this terminal because, oh, I don't have a network. Oh, yeah, I do. It's just very, very slow. Okay, so there's a one node cluster running in Google. That's my Kubernetes cluster. So, I can just show you this file. So this is the file that I've just gone through. Nothing really interesting here. The way things are typically submitted, of course, there's an API. I find it easier to use the CLI even in automation. So let's submit this, and I think I can add a watch to it that will sort of wait for, and we can have a look at what this looks like. So now it's actually sort of already at stage 2. It is initializing the pod. Consume has been run. It's now executing the last one. And hopefully this will finish soon, because that's the simplest step. Yeah, and it's done. So that was a very, very quick quick run through of the thing that I showed. Argo has, so I can have a look at sort of the logs for. Why? Okay. No. Why did that? Oh, I was pasting something else in. Okay. Yeah. Yeah. So basically, that I have done my calculations and have calculated a number. Woohoo! Okay. Questions so far? No? Okay. So, things I've learned so far. There's a bug in Argo which really annoys me, that all tasks are evaluated, even if they're not supposed to be executed, because you have things like conditions. So you want to say, like, this step should only run under certain conditions. Like it's for instance, you want to reject data, and then you don't want to run all the steps. It will still evaluate all the steps. And if it can't find the artifacts for all the steps, it will mark the flow as a failed flow. It's been the bug report has been accepted, and they will likely fix it at some point. I find the syntax perhaps too flexible, and when these workflows get into like 1,000 lines or 2,000 lines, they get long and complex. It's YAML, and it's debugging it is sometimes painful. You have to sort of stop and check a lot of the time when building the flow. If you sort of write 1,000 lines of YAML and then just expect it to work at the first try, you will be sorry. Yeah, and the decisions are like if you do this with Airflow, you have all the tools in the Python tool chest in order to sort of only execute this step on a Wednesday if it's after 1 o'clock, right? You can do that's easy in Python. It's not easy in YAML. You can do it, but you have to sort of create an extra step that will sort of then where you stick the Python in that step, and then you have to sort of output an output variable and then do a condition on that. Documentation is mostly in the form of examples, which is sometimes really nicely, but since there are so many ways of solving the same thing, you have 5 different examples that are sort of similar but not the same. So for instance, you don't have to define the workflow as a DAG. You can use it in the first format, which was steps, which is completely different. And these examples mix and match, as some of them are using DAGs, some of them are using steps. It's not always, you can't really just cut and paste from them and sort of mix them together and expect it to work. Yeah, that's it. There's tons of stuff I haven't touched on. There's loops, for instance, which are interesting. I think you actually can have things which are not really DAGs, like you can retry a step again and again until it succeeds. It's not really strictly a DAG. Community is pretty helpful. There's a Slack channel that's not that helpful for beginners, but if you file issues, they're really attentive. And they guided me through the first bug I submitted. Instead of solving it, they told me how to solve it. And they spent quite a bit of time to sort of bring me on as a contributor, which I found nice. Questions? Okay.